Let's play around with some equations today. Hi, and welcome to Algebra Examples. I'm Dr. Finch. I have a PhD in mathematics and over 20 years of experience in math education. Today we're going to look at a fun problem where we're letting our function be x squared, so something simple, something we're used to, and we are going to verify or show that the following equations are true. And we have four different things that we have to show. If you struggle with putting things into functions, working with functions in that way, this is a good video for you to get that practice and to show equalities practice as well. All right, let's get started. We have four things that we want to prove. So I'm going to draw a line here and we're just going to dive right in. So we have our first one is we want to show f of negative x is equal to f of x. And we know that f of x is equal to x squared. Now, what we usually do, remember, is that we take whatever is inside the parentheses and we just punch it in where we see that x in our equation. Now, I know a lot of you are probably taught in middle school and high school that if you are just looking to verify something, you just, and do not do this. It's going to drive me nuts if you do this on your work. You just punch it in and then you say, oh, it's going to be x squared is equal to x squared, and we're right. Okay, don't do that. That is bad. Why is that bad? That is bad because we don't know that this equality is true. So we can't operate on that assumption and keep on saying it as equality throughout our problem. It is going to drive your professor nuts. Some teachers are okay with it. I will say some of them are fine. Check with your teacher. A lot of them, oof, it's like nails on a chalkboard. So we're going to learn two methods to show this that avoid doing that sort of it's like fuzzy math. Let's call it fuzzy math. One method is going to be starting on one side of our equation, and then we're going to do a bunch of things, and then we're going to reach the other side of our equation. So we're not going to assume equality anywhere. We're going to show equality everywhere. So we're going to start off with the left-hand side of our equation here. We are going to take that negative x, and we're going to punch it in where we saw an x. Now, the crucial thing here is you'll notice I put parentheses around our negative x. Make sure you do that if you have anything other than a single letter or a single number in there. Always use your parentheses. They are your best friend. They will always help you out when you're doing algebra problems. If you don't have them in there, you may suffer, and we don't like that. So keep them in there. Oops, let me make that a little bit prettier. Now, the reason why we need that is because negative x can be rewritten as negative 1 times x. And once we have that, we can distribute our squared into the parentheses. So we get negative 1 squared times x squared. And negative 1 squared, there's two negative 1's there, so that is a positive 1. So that gives us x squared, which, as we'll see up here, is the same as f of x. So you'll notice we didn't assume equality anywhere. We started on the left-hand side. We did a bunch of work that we all know each of these is true, and we ended up on the right-hand side of our equality. So that's the first method to show that you have equality for two things. All right, let's look at the second method. Our second method is going to be, we're going to use that for this equation, y plus x. Okay, so we want to show that f of y minus f of x is equal to y minus x times the quantity y plus x. And we're going to start off on one side, f of y minus f of x. We're going to punch those into our function. So we're going to start off everywhere we saw an x, we'll put a y. So we end up with y squared. We don't need parentheses this time because it's a single number / letter. When it's just one thing and there's no negative signs or anything tagging along, you're fine just punching it in. So we get y squared minus x squared. Now, if you wanted to, you could factor this and get to the right-hand side of your equation. I think that sometimes that can be a little bit tricky for some folks. And so it's nice to also instead, here's a different way of doing it. We'll now go to the next line and we'll start on the right-hand side and we'll see what we get. So let's distribute our y value. We get y squared plus yx, and then we keep on distributing just so that everything is punched out. Minus xy minus x squared. Notice our two terms in the middle. We have a plus xy minus xy. So we get y squared minus x squared after they cancel out. And ta-da! They are the same thing. So what we've done here, instead of going from one side, doing a bunch of work and getting to the other side, we started both sides separately and we met somewhere in the middle. So meeting in the middle is the other way to show inequality in a nice format. I like the meeting in the middle one. Sometimes that's easier. Depending on the problem, see what works for you. All right. So part C, let's make that a little bit prettier. X plus h minus f of x. For those of you who are going on to take a calculus class at some point in your life, you're going to get sick of this. You're going to see this a lot, at least in Calc 1. And after that, not as much. Okay, so in this case, notice we have two terms that our function is eating. When our function eats two terms, we want to use our parentheses to punch that into our function. Remember, our function is f of x is equal to x squared, right? So we want our x, whatever our function eats, we want to square it when it spits it out. Our second term is just minus x squared. That one we don't have to worry about as much. All right, I'm going to write out some details here. If you feel comfortable doing this without writing out the details, go ahead. But beware, sometimes writing out the details can really help with your algebra skills and practicing that. It can also help if you make a mistake to see what might have gone wrong. Okay, so we're going to distribute now. We get our x times x gives us x squared plus x times h plus h times x plus h times h, or h squared, minus our x squared. We have two copies of x squared, one addition, one subtraction, so those two are going to cancel. And now we have xh plus hx. Those are the same thing. So we have two copies of those and one copy of our h squared. All right, that is beautiful. So we started with the left-hand side, we did a bunch of work, and we ended up on the right-hand side of our equation. So this one was one side to the other. And you'll notice that we kept our equal sign kind of in the aligned right here, so we could just follow the work down, which is super nice if you're doing it that way. If it's not going to fit on one line, that's the best way to go about it. All right. Oh, I hope you're ready for the last one. Square roots and absolute values. Hurrah. So, square root of f of x is equal to the absolute value of x. Oofda. Okay. Let's do a couple things before we even start here. I want to do a recall, because it's always good to remind yourself what the definition of an absolute value is. It's actually a piecewise function. There are two parts to it. It means you just spit out the same number if what you put in was bigger than or equal to 0. and you spit out negative that number if it was negative to begin with. So everything turns positive. Just as a reminder, I'll just show you on the graph, absolute value of x. Oh, this, okay, ends up being like a V on your graph. So that is y is equal to absolute value of x. That's what it's going to look like. It just turns everything positive. All right, we're going to start off with the part that looks really gunky with the square root on the outside. All right, so f of x is equal to x squared. So we're going to replace the f of x with our x squared, right? And notice what happens when we square and square root something. We get the same value back. But notice here, x squared is what we start with, and it's bigger than 0 always, isn't it? It doesn't really matter what number you punch in, you square it, you are always going to get a positive number or 0. I suppose I should add the 0 if you start with something that doesn't matter what number you punch in. Okay, so what that tells us is when we take the square root of that positive number or 0, that number will also be greater than or equal to 0 always as well. So it really doesn't matter what number you start with. You are always going to get something that's positive, and they're going to cancel each other out. So you get a regular x, but it's not quite x, it's absolute value of x. So there we go. Whew, that one was a little bit more of a mind bender. I hope you enjoyed it. If you have a question that you'd like to see solved, please email me at purplefinchmath@gmail.com.